There you go.
Listening is recorded.
All right, so 2.3 deals with finding the domain and range. So we'll start out playing with a couple graphs, looking at the graphs and finding our domain and range and answering those questions. Then I'll show you how to find a domain of a function, and we'll work some of those problems. So remember, when I talk about the domain of a function or a graph, the domain is the set of all x values. So domain, set of all x values. And then we look at the range in this section. And for us, the range will be the set of all y values. You can also hear the domain be called the independent variable because you can pick any x's, and the range would be called our dependent variable because it depends on what x values you pick to get to y. So independent and dependent. So y'all, first off, I'm going to draw us a graph here. X and Y table, and throw some points on it for us. Oh, and I'll probably number out about 6 on this. All right, y'all, let me let one in real quick. All right, so let me put some points on here real quick. So I'm going to put a point over here at -1, 1. So go left -1 and up 1. I'm going to go left -2 and up 2. Left to -3, up 3. Over here at -4, I'm going to go to 4. So these points are -1, 1, -2, 2, -3, 3, -4, 4. All right, then I had a point over here at 0, 2, 1, 3, and then at 2, 4. So there's 4 things they're going to ask us on these first 2 problems. First of all, on this problem, they want me to find f of a -3. So y'all, what this is telling me, since there's a number in place of the x on this, they want me to use that number for x and find the y value that corresponds with an x value of -3. Okay, so what y value corresponds to an x value of -3? So y'all, what y'all think? Find me -3 on there for my x and see what that y value is. All right, also here's my x-axis. So let me go over here's -3. And the only point at -3 is my second point from the left. So let me pull up chat and see if y'all got that going in there. All right, so my chat's saying -3. Well, remember, we're looking for the -3 for the x value, but what I need to know is what's the y value of that point? And remember, if you draw right across there, you can tell me it is definitely 3. Good job. So y'all, that means f of -3 equals 3 because that's the y value that I got at -3. If I was looking at, say, this one's for y'all just to see what y'all say, but what would y'all put if I said f of 0?
2,
Oh, I think I heard it.
2.
2. Good job. Because when x is 0, we go up, and that point is sitting there 2 on the y-axis. Good job, y'all. All right, so next, they want the domain. Now, for the domain, they're going to give us the set parentheses. All we got to do is put our domain in here. And since this is separated by points, we'll put each of our x values in there, comma, then the next one. So y'all looking at this far left point. What is the x value of my furthest point?
4.
Oh, y'all are so close, not the y value, but give me that x. So come straight down.
-4.
Negative.
-4.
All right, next point.
-3.
-3. Yeah,
Oh.
all the x's I need. This point looks like what, -2, -1. All right, this point. I think I heard it.
+2.
Oh, remember, go back to the x's.
0.
0, there you go. This point,
1.
1, okay, I come straight down, and then this point comes straight down from the x value
2.
is a 2. So that's all I want when I ask you about the domain. I just want those x values for all these points, okay? All right, so C is about the opposite of A. For C, they want any x value for which f of x equals 2. So remember up here, they gave me the x of -3. I found the y values. But now they're telling you that the function equals 2. So they're giving me the y value of 2. They want me to find any x's where that happens. Hey, y'all, one of y'all is getting a little loud. I might have to have one of you.
It'll be 4.
Oh, hang on. So let me put it. So they'll put x equals. So let's see. So I want a y value of 2. So my y value of 2 comes straight across right here.
Okay.
So this one has a y value of 2. This one has a y value of 2 because they're both horizontal across there. So what x's did that happen?
Kind of hard to hear. Her mic is on. She has to
Yeah,
turn
I
her
can
mic
hear
Well,
off.
who is this when I'm trying to figure it out?
Jalissa Johnson. I'm not sure, but it's just.
I might have it now. Okay. All right. So y'all, here's the question. Here's my y values of 2 going straight across that line. What x values does that happen at? So there's your first point, right? And the y value of 2.
-2.
So that looks like a -2. And I had, I got this point sitting right here. It has a
Zero.
y value of 2. So what's this x?
0.
0. So since I had 2 points with that y value, we had to get 2 x's for that, okay? Then finally, they're going to want the range. Now, remember, ranges are my y values. And they're going to give you the little set brackets again. And all we got to do is put our y values. So usually when I do the y values, I start with the bottom and go up. So here's the question. The point down here in the V, what is its y value?
1.
All right. The next ones are these two right here. What is their y value?
-2 and 0.
Oh,
No.
don't go to x's.
Positive 2
Oh.
and 0.
So there'd be positive 2 on those, remember? So don't worry about the x's, only the y's. So let's redeem ourselves on this one. You got 2 points right here. They're the next ones in order. What is their y value?
3.
Now, I got 2 of them that have a y value of 3, so I only have to lift it once, okay? When you got repeats, just lift them once. So y'all, what is the last y value on there?
4.
4.
Definitely 4. Okay. So remember, domain, you look through them points and you just tell me the x coordinates of every point. The range, you're going to go through and tell me the y value of every point. All right, let me let one in real quick.
Hey, can we revisit C again?
Can we do the what?
Can we revisit C again? Because it says for any x value for which f of x
So
equals 2.
C, they're going to give you something like this. And this one said any x values for which f of x equals 2. Well, what this question means is what x values have a y value of 2. So that's when I drew this line across there, because remember on the y-axis, 2 is the second one up. So you draw a horizontal line across there. Any point that is on that horizontal line has a y value of 2. So then I went over here and I said, well, this point hit that 2, right? So I looked straight down at its x value, and it was sitting at -2. And then this second point here on the y-axis, it's at the y value of 2. So once again, I just looked down at what that x value was here. And remember, when you're in the center, x is 0 at that point. So did that help on that?
Yeah, I get it, but I just.
Well, I got another one coming. So maybe this one will break the, get more confidence. How about that? All right, so on this one, we're going to draw another graph, but it's going to be a line instead of points. So go out about 5. All right, y'all, let me see here. So my point, my V of my line is going to be right here at 2 on the x-axis. And it's going to go up to the right. And then it goes off to the left. I'm trying to get it sort of close to the 2 on the y. Mine's a little messed up. All right, so same thing on this one. They want to know what is f of 2? Remember, to find me f of 2, you're going to need to know what the y value is when the x is 2. Oh, I see y'all holding up a 0, it looks like online. So definitely f of 2 equals 0. Now just go on the x-axis, here's 2. The point is right on it, so that has the y value of 0. All righty, so this is going to be a new one on you. But we're looking at the domain, which is all the x's. We all look, this graph goes on forever toward the right. This graph goes on forever towards the left. So towards the right, it's headed towards infinity. To the left, it's headed towards negative infinity. When a graph covers all the x values, we say that the graph is good for all real numbers. Okay, because we can't sit and list all these numbers. It'd take us, well, we would never do it, right? We would be from 1, 2, 3, blah, blah, blah. So when that's the case, you put all real numbers and you're done with it. All right, y'all, so any x values for which f of x equals, let me see what I wanted there. For which f of x equals 2 again. Now this one's going to be sort of tricky because my point's a little off from what I needed, but I would draw me a line going straight across at that 2. So I was wanting this one sort of to hit it right on the y-axis here. So I'll give you the first one. The first one I was wanting to hit it on that y-axis. So that would be 2 right there. So that x value right here would have been a 0. So it hits it right here also. You know, it looks like the closest point I got there, if this would have been drawn good, would probably come down there and be a 4. So A and C are opposites of each other on these questions. Here they give you the x of 2, you found the y value. On this one, they give you the y value of 2, and you found me the x's, okay? And y'all guess what the last thing for this one is? The range. And now remember, the range is my y values. So here's the thing. You got the lines going up. Can I use all real numbers for this one? No, good job. Because there's nothing negative on this. Okay? I can use all the positive real numbers because my graphs are going uphill towards positive infinity. But I cannot use all real numbers because I don't have anything in these negative y values. So for this one, they'll give you they're letting you know that the Y is your range. And now what do we know about the Y? We know that Y has to be greater than or equal to what number, y'all? What is my smallest Y value?
2.
Oh, so remember Y value of 2 is this line. I got points lower than that line. Oh, Ashton, you got it on there. You got a 0. Good job. I think I see one being held up online now. Kayla. Yeah, 0, y'all. That's the smallest Y value right here. And I'm not negative, so this would say Y had to be greater than or equal to 0. Okay. So that's what we're going to bug y'all with. You're going to have 2 graphs. One's going to have points. One will have lines like that. Just remember what they're asking for. If they give you the X, they want the Y. If they give you the Y, they want the X's on those, okay? All right, y'all, so that leads us into the next thing on domains. We're going to find the domain of a function. Okay, so before I give you the steps, let me tell you there's only a couple things I'm worried about when I'm looking at a domain. So y'all, let me ask you this. What if I had a fraction? So y'all, for this fraction, any number divided by any number, can you think of any restrictions you might have when you're dealing with a fraction?
The numerator being bigger.
Okay, say that a little more. You're on the path, I think.
The numerator being larger than the denominator.
Oh, now we can do that. We just call them improper fractions, but that still gives me a real number that I can do, like 7/5. Remember, that's still a good number.
If you have something that equals a whole number,
Oh, okay. So y'all, let me get y'all back onto my right track. Can you divide the bottom by every number that you know? All right, let me ask it like this. Can I divide the bottom of a fraction by 0?
No.
No.
No. Yeah, no.
So remember, if you try to do something like this, 2 divided by 0, you can't do that. That is undefined. Okay. So if I got functions that have variables in the denominator, I got to make sure that that denominator does not equal 0. Because if the bottom equals 0, you're going to get an undefined error message on that calculator, and you cannot graph that, can you?
Nope.
We cannot graph anything that's undefined. Now, you can put a 0 on top. 0 divided by 2 is 0. But 2 divided by 0 is undefined. So the moral of the story, B cannot equal 0, okay? Now, that means when I'm looking at functions, if it's a fraction, I got to figure out if there's any numbers that'll make it undefined on that, okay? Now, later in life, they don't hit you with it in this section as far as doing domains with it, but radicals, like square roots, later in life, there might be numbers that I can put into a square root that would make it imaginary. But they don't hit us with that in this section, so we're going to hold off on those. So the moral of the story, the only thing I'm worried about in this section when I'm looking at domains is fractions. If it's not a fraction, my domain will be good for all real numbers. So the first step, do I have a fraction? If not, then the domain equals all real numbers. If the function is a fraction, well, think about this. With my fraction, I didn't care if the top was a zero, y'all. The top could be zero all day long. I'm only worried about that denominator not being zero. So since I'm only worried about the denominator equaling zero, I set the denominator equal to zero. So I set my denominator equal to zero. That way I can solve for the variable. Solve it for that variable. Then I exclude any solutions from my domain. And then I'm going to put it in set builder notation. All right, so set builder notation will look like those fancy little parentheses. You list the variable, so my variable will be X. The little bar right here, the little bar means such that. So we're saying the domain is the X's such that X is a real number. And X cannot equal whatever number we get. So whatever we get for our solutions, we'll put X cannot equal that number and be done. So this lets us know that this domain will work for any numbers except for that number that made my fraction a zero in the denominator. And once again, remember, if you don't have a fraction, all real numbers. Okay, and I'll sort of play with y'all on some of these examples. So these will start about number 3. The first 2 problems was doing the graphs. So number 3, on these examples, they want us to find the domain of the function. So for 3, y'all, they got f of x equals 13 divided by x minus 3. So we actually have to do work on this one because I got a fraction. And I got a variable sitting in that denominator. So it's possible there is a number out there that when I plug it in for that x, makes that bottom equal 0. So what would you do to this? You would take that denominator, x minus 3, and you set it equal to 0. So y'all, the only question is, give me one move and we can solve that.
Add the 3 on each side.
Yeah, that's all I got to do. Add me a 3 to both sides. So x equals 3. Well, that sounds good. 3 minus 3 is 0 when I plug it in. 13 divided by 0 is undefined. So that checks out. So now we put our set builder notation, or x, such that x is a real number. And x cannot equal a positive 3. But y'all, that means that this will work for any other number we got out there. We could put fractions in for that x. We could put negative numbers in for the x, any positive numbers in for the x other than the 3, and it would give us a real number, okay? All right, y'all, so remember, fraction, set that bottom equal to 0, solve it and be done. So find the domain of this one. P of x equals 2x minus 5. So any guesses for my domain? So let me ask y'all this. Do y'all see a fraction there?
Yeah, to get x by itself, it would be -5/2.
Oh, we are doing too much work.
Oh, okay.
Think about this. Do you have a fraction? So since I don't have a fraction here, I don't have any restrictions on putting the number in for that x, can I? Because any number I put in for x, I can multiply by 2 and then subtract 5. So you remember my first step. Let me go back for y'all. First step we said, do we have a fraction? If not, then the domain equals all real numbers. So I'm coming back to that number 4. There's no fraction here, so automatically this domain will work for all real numbers. There's nothing I can put in for that x that when I multiply by 2 will make that thing undefined at all. So y'all, it all goes back to that one thing I said. We're only worried about fractions for these domains, okay? All right, so I'm gonna let y'all redeem yourself on this one. I've got a P of x equals x squared plus 9. So what is that domain?
All real numbers.
All real numbers. No matter what I put in for that x, I can square it and add 9 to it, okay? All right, g of x equals 2 divided by 3 minus 2x. So guess what? We can't say that on this one. This one is a fraction. So since it's a fraction, we're going to take the bottom and set that equal to 0. So you're going to have 3 minus 2x equals 0. All right, so I'll let y'all solve me. What y'all want to do to that?
Guess we gotta subtract 3 from both sides.
Are you saying the 3?
Yes, do we have to subtract 3 from both sides?
I can do that. So I get negative 2x equals negative 3. All right.
And then divide by 2. -2.
So divide them both by that negative 2. Whoops. I'll see, let me see. Negative 3 divided by negative 2. All right, so these x's cancel, these negative 2's cancel, you got your x. So what's a negative 3 divided by negative 2? Them two negatives will make that
Positive.
positive. Good job. So we got x equals 3/2 for our solution. So y'all, you're going to come up here. X such that x is a real number. And x cannot equal, oh, what did we get? A positive 3/2. All righty, y'all. So remember, we've done a few of these now. A fraction, I was worried about fractions, so I set the bottom equal to 0, got my number, excluded it. 4, I didn't have a fraction. So since I wasn't worried about fractions with that, it works for all real numbers. Same thing with 5. You didn't have a fraction, it worked for all real numbers. 6, once again, we did have a fraction. So since we had that fraction, we set the bottom equal to 0 again and got that solution. All right, let me fix this paper. So that puts us on 7. For 7, they got P of x equals the absolute value of x minus 5. So let me throw some absolute value at you and see what you do. Do y'all got any restrictions on absolute value?
Shouldn't, since it's gonna be a positive number.
Yeah, because you can throw anything you want in there, fractions, decimals, negative numbers, positive numbers. All that's doing is making them positive, like you said. So then that makes my domain what?
All real numbers.
All real numbers. Now, we'll say in Math Lab will do it like this sometimes. Instead of writing all real numbers, they'll do x such that x is a real number. But they'll put them in them little fancy parentheses, okay? So either way, they're liable to hit you either way when they write real numbers. All right, so y'all did good on that, and let's see what y'all do to 8. P of x equals x to the 3rd minus 1. So is that cube giving you any restrictions? No, good job, because I can throw anything in there, multiply it times itself 3 times and still have a real number on that. So since there's no restrictions, what is my domain?
All real number.
So when the domain is all real numbers, do we have to put it in those parentheses?
It just depends on how they write it. These ones on these questions, they're like A, B, C, D type answers with the stuff written out on them already.
Okay.
And you just got to find the one that might have it like they're writing it.
Okay, gotcha. Thank you.
Mhm. Most of the time, they're sort of doing it like what I got in my parentheses, though. All righty, y'all. So questions. So what I'm going to do, that's all the homework for 2.3. So what I'm going to do is review y'all a little bit before I let you go for this. And then I'll leave it open if y'all got support questions and stuff. I'm just going to sort of refresh y'all on a little bit of stuff that'll help us Wednesday. So y'all do this. I got a -2a squared. And I'm going to multiply that by a 9a squared b squared. Do y'all remember how to multiply these?
You distribute the outside number to each number that's in the inside.
Yeah, sort of.
Then you just add
But really all I'm going to do is multiply this stuff out here by whatever's inside here. So watch this. The only thing over here that -2 can multiply by is what?
9.
That 9. So multiply that -2 times 9, that's going to give us what? A -18, right?
Correct.
Now the A, there's only one thing over here that A can multiply by. And that's the one that looks like it, right? A's can multiply by A's and change their exponents. So here's the question. A squared times a squared gives you what?
4.
A to the 4th. There you go. And really all you're doing is, since the A matched up, add those 2 plus 2 and you get a 4. Now, all that's left over here is a b squared, right?
Right.
Well, is there anything over here that's going to change that b squared?
No.
No. So that b squared is going to stay the same and tag along at the end. So when you're multiplying, numbers can multiply by numbers, and like variables can multiply by like variables. If you got another variable in there, if it ain't got something over here that looks like it to multiply, then it stays the same, okay? So let me try another one with y'all. This get y'all good at this. How about a 5x squared times a y? Let's multiply that by, say, a -5x squared y squared. Now, the reason I'm not distributing all these times everything through here like you would when you FOIL is because nothing in here is being added or subtracted. So we're just finding what looks the same, multiplying it and being done. So y'all, what's the first thing you're writing over here?
5 times -5,
Which is?
-25.
All right, continue on.
X to the 4th
X to
power,
the 4th power.
Yep.
y squared.
Y squared.
Oh, y'all are so close.
Oh, y to the 4th power, or no, 2nd power.
Y to the
Y to the 3rd. Power.
Y to the 3rd. Remember, if there's not an exponent by the y that I have out front, we put a 1.
One.
There you go. So that the 1 and the 2 gave me my y to the 3rd. Good job, y'all. So, oh, let me think of something else that'll hit us. So we're going to have to know how to add polynomials. Now, when you add polynomials, you can drop these parentheses and keep all the signs the same. So let me put numbers out here so we know where I'm starting at on this. So this is my number 3 problem. So since it's being added, I can drop parentheses and keep all my signs the same. So that's a negative 7x squared. So that'll be negative 7x squared minus my 2. So both these were positive, both these were negative.
Mm.
So can y'all go further with that?
Yes.
All right, so what do you get?
Negative 5x squared plus 1.
Oh, good job. So you took the x squareds, those were like terms. 2 minus 7 gave us negative 5. And then the numbers were like terms. 3 and negative 2 gave us a 1. Good job. Can't go no further. Final answer.
I'm sorry, I had a question for number 2.
On number, which one?
2.
Okay.
That because you multiplying, like where you get the 1 and the 2, like I'm not understanding that.
Okay. So when I started, I didn't even have no number here.
Right.
I just had 5x squared y times negative 5x squared y squared. So I started with my numbers. 5 times negative 5 gave me negative 25.
Exactly.
I went with the x's. I had an x squared and an x squared. Well, when you multiply x's times themselves, you add the exponents.
Gotcha. All right.
So I added those exponents and gave me my 4. Now here I had a y and a y squared. This y didn't have an exponent. So if there's not an exponent there, it can't be a 0. It's got to be a 1.
Okay, I understand now. I was just confused because we started off with
1 and 2 and you got me a 3 on that, okay?
Gotcha. Thank you.
All righty. All right, y'all. Negative 3x squared plus 5x minus 2 minus the next polynomial, which will be, oh, what I want here. How about a 2x squared minus 7. Now, subtraction is almost like addition, but when you subtract, you gotta distribute the subtraction through the parentheses. So we must distribute subtraction. Now, when I drop the first parentheses, these all come out the same as they look. Negative 3x squared plus 5x minus 2. But now we distribute our subtraction. So when you subtract a positive number, that's like a negative times a positive. We'll keep that negative. And then you bring down your 2x squared. But y'all, let me ask you this. What's going to happen when I subtract a negative 7?
Positive.
There you go. Because that negative times negative will make the 7 positive. So when you subtract, everything in the second parentheses will change signs when they come out. All right, y'all. So how about this? Can you go further?
Yes, combine like times.
Mhm.
Yes.
All righty. So what y'all getting?
Negative 5x squared.
Negative 5x to the second
Uh-huh,
plus 5x
because there's a 5x and nothing else to add to.
plus 5.
And then you got the 5 because the 7 and the -2. So good job. Just watch out when we start subtracting these things come Wednesday. We always want to distribute that subtraction. All right, y'all, so let me do one more. X plus 3 times X plus 4. All right, notice up here you had a plus in between the parentheses. Here you had a minus in between the parentheses. Here you have nothing. So parentheses next to parentheses, we get to multiply this. This is where they might have taught y'all FOIL and all that fun stuff. So you take the X, distribute it through the second parentheses, and then you get that 3 and distribute it through the second parentheses. Both of these multiply by both of those.
Mm-hmm.
So y'all, we got an X times an X.
X to the second.
X to the second.
And then you're gonna
we're really adding them ones that we don't see, right?
mm-hmm.
All right, how about that X times that 4?
And then you're gonna let's see, X times the 4
4x plus 4x.
All right,
plus 4.
and so I'm done with the X. Let's do the 3. A 3 times an X.
3x.
And y'all finally, a 3 times a 4.
12.
Yeah. Now, y'all, the biggest mistake I get on that, people add the 3 and 4, make it 7. But remember, multiply everything. All right. Can you go further?
Yes.
All right. So what y'all get?
X to the second plus
7.
7x
Uh-huh.
plus 12.
That's 12. Okay. So if you wanted to be a little ahead before the next class, because tonight's lesson didn't have a support, but the lesson Wednesday has a support doing this kind of stuff, and knock it out, and then that makes your next night a little bit shorter for you. That'll work, but no, I just wanted to give you a little review, doing a few operations, because that's what's coming up next is a little bit of algebra like this, okay? So let's see, that is all I have for my college algebra lecture. So what I do now, I'm going to leave the Zoom open, and I'll probably quit my recording in a second. I'm going to leave my Zoom open, I guess, for the next hour. If you're doing any homework and you got any issues, pop in on that Zoom and you can ask me any questions you might have through that next hour. It's almost sort of like you got a tutor available for about an hour, okay? So we use that support lab to help y'all with any problems you have as far as any homework up to now and so forth. So remember, right now we did 2.3, so you had 2.1 and 2.2 last week. So y'all, let me quit our recording. That way I can send this out later for our lectures.